Welcome back to the channel. Hope everybody's doing well, and in today's video we are taking a look at the TIS570 AC/DC earth leakage clamp meter from Test Instrument Solutions. If you've not heard of them, Test Instrument Solutions are a UK based instrument manufacturer established around about in 2005. Now, I don't think you can buy direct from Test Instrument Solutions themselves. I think you buy these through electrical distributors throughout the UK and Ireland, so I don't think they have any presence in mainland Europe or other parts of the world such as America. They do, however, offer a calibration service for their instruments, so presumably they can actually adjust the calibration on these should you find them to be out, and then they may well be able to calibrate other manufacturers' equipment, but they may not be able to adjust them. It will just depend on what arrangements they have with other manufacturers. The range of instruments that they provide, I would say, are predominantly aimed at the domestic/commercial installation market, although they do offer a few other instruments aimed more at industrial use. As far as I know, TIS themselves get all their equipment manufactured for them. I don't think they have any of their own manufacturing facilities. If you look amongst their instruments, you can see instruments that are from Bryman, SEM and Unity, and they also seem to market a lot of instrumentation from HT Italia, who's an Italian equipment manufacturer, and indeed this TIS570 is exactly the same as the HT79 by the looks of it. Now, whilst HT Italia do have their own manufacturing, they don't manufacture everything of their own, and I do not believe that they manufacture this clamp meter. I believe this clamp meter is from the Center Technology Corporation of Taiwan, and is in actual fact the Center 262. The Center Technology Corporation, they were established back in 1998, and they do offer quite an extensive range, up to around about 25 different types of clamp meters, and then they dive off into the other types of instrumentation and equipment that they offer. And if you also look at Martindale, it looks like a lot of their clamp meters come from the Center Technology Corporation as well. So the main thing about this instrument is this DC earth leakage function that it offers. I've only really been able to find one other instrument, which is the Unity UT258A, which looks to be the same as the Cisco LCC M60, that offer AC and DC earth leakage measurement. So that's what makes these clamps quite a bit more interesting, because measuring DC through a clamp function can be quite onerous, especially down in the low milliamps level. So this is the instrument that you see in front of us. It comes boxed. I'll flip this over and you can see all of the functions that it provides. You can have a read through them yourself. One we're interested in here predominantly is this DC current, 0 to 10 amps, but with a resolution of 0.1 milliamps. However, we do have an accuracy of 1% plus 10 digits, so that 10 digits already puts us into plus or minus 1 milliamp accuracy level there. So that's this little box. Inside the box it comes in this little wallet. We do have a little belt loop around here as well, a pouch kind of thing. There is a little bit of padding to all four sides of this, the front two sides and the lid there, and in the bottom as well it is a little bit of padding in there. There's our instrument, and inside we also get a little instruction manual. We can also download that instruction manual from the TIS website. And it does come with batteries, and it does come, there they are, with a set of leads as well. These are not fuse test leads, just general purpose. I think they feel PVC, I don't think they're a silicone one. But they're not too bad. I do have the GS38 caps on them for use in the UK. No crop clips or anything, but you should be able to get a clip-on crocodile clip to go over them should you want to. And they're not bad, not too bad for access into terminals. Let's have a little look at that a little bit later on. So this is our meter itself. We do have a central control function switch here in the off position. Our first position is DC amps there. And we do have a zero function for that as well, so we can zero the reading, and we do have a min max should we want to. Zoom, yeah, it's just min-max, it doesn't appear to give an average, and we do have a hold as well. And then we go on to amps AC, same functionality to the 0, doesn't matter, but we can use min-max should we want to. Volts, min-max again, and our hold function will work with volts as well. And then volts DC, will be the same again. Yeah, we can 0 on volts DC as well, should be measuring millivolts, so it's got that functionality. And then we have ohms, and a don't know whether we can 0 the ohms or not. Yeah, we can, so we can 0 the ohms as well. And then a long press of the min-max will flip us over to continuity. I don't know what that buzzer is like. It's a fairly loud buzzer, but not particularly fast. And this is just a continuity, there's no diode measurement on this. So that's the basics of the instrument. We'll get this knocked out of the way, set up some test apparatus, and we'll see how well it performs. So we are injecting some volts from our SMRT injection test sets. We are set up to read AC. You can see our key site here is displaying 230 and 50 Hertz there, and we've got 230.0 volts on our TIS570, which is all good. We'll just convert this to 120 volts for our American friends and 60 Hertz. Little button there, so you can see again now we are 120 volts, 60 Hertz, and we are 120 volts on our TIS570. I didn't display this, we also have a light on here, so you can see the light is pretty nice. No real fading on it anywhere that's noticeable, but it's not constantly on, it's a timed light, it will go off after a few seconds, about 20 seconds I think. So that's our AC voltage displayed there. We can turn him off, I will convert everything to DC. There's our DC displayed there, 119.9, but also 119.9 on our key site as well, which is all good. Let's just pop him up to 230. High voltage there, 230 against 229.93. So all those DC measurements are good and accurate. So now I need to have a change around to test the current function on the clamp. So we are set up on AC amps here, injecting 10 amps, which is 50% of the full scale. Max we can read is 20 amps. We are 50 Hertz. And you can see we are 10.01, so pretty much smack on. I know this is quite a small head, but we'll just move it around and just see what variation we get. 10.01 top, 10.01 bottom, 10.01, so you can see it's a very, very stable clamp meter in that respect. No problems whatsoever there. We'll just flip this to 60 Hertz. So we can see there 10.02, so we can see it's shifted 0.01 amps, and even then it's floating around, so that's perfectly acceptable. Now we'll just switch off and convert this to DC. To flip him over to there. So now we are DC amps. 0.03, we can 0, but we're 0.02, so we will switch back on. So this again is half full scale, 5 amps, and we have 4.98, so a little bit out. And let's just switch him off. We will 1.7. So we'll 0 that, and we'll just switch back on again. And we've got 5 exact, so yeah, you can't complain at that, can you? Nothing wrong with the DC amps measurement there whatsoever. What I'm going to do, I can do milliamps with the SMRT, but it's not very stable, below 100 milliamps really. So what I'm going to do is just shut this all down and set up a different test set to verify the milliamps capability measurement of the instrument. So we're now set up with our mere test unit, and we are back injecting AC current. As you can see there, we are on 0.4 amps is our setting, 400 milliamps. You can see we've got 0.401 displayed on our TIS570, and on our keysight we are 399.3 milliamps, and you can see the 50 hertz up there. If we can go to that to 60 hertz, you can see there's no variation whatsoever, so we are all stable frequency wise. With regard to our range change, let's just go down to 300 milliamps there, go down to 200 milliamps, and you can see we've now changed range and we've got the extra resolution, the 0.1 milliamp resolution, 200.2 against 199.84. If I go back up to 300, you can see that we still retained our 0.1 milliamp resolution on this occasion. So when we're going up, we retain it. When we come back down, we stick at the 3-digit resolution, the 1 milliamp resolution. So it looks like our range changes around about the 300 milliamp mark. We'll just take this all the way down to, let's go to our American friends who are on 6 milliamps RCDs. You can see we've got 6.1 milliamp there, 5.988. Let's shuffle our clamp around, and you can see this is a very, very stable clamp meter. It's not moved at all with regards to the position of the clamp. There's our 60 hertz there. Again, we're still all stable, no problems whatsoever. So let's just convert this over to DC. So you can now see we are on DC milliamps. We are 0.395 against 399. What we just need to do is turn that off, and we need to zero our clamp. We'll switch him back on again. 394, 393 against 399. So we'll just go down to, there's our 300 milliamp there. 294 gets 299. A little bit out. I thought I got this better than this when I did all my tests originally. 201 gets 199.98. And let's take this one all the way down to our 6 milliamps. 6.2, 6.1 against 6.04. So that is a seriously accurate for DC really. 6.2, 6.03. Okay, it shifts a little bit with DC. 6.3. 9. Okay, what may be the difference is when I tested this originally I didn't have this in, I just relied upon the calibrator sending out the right reading. So this might be affecting the performance a little bit. It does sometimes happen when you start putting meters in series with other things. But essentially that's pretty accurate, pretty stable. It's pretty good. I mean, we are talking couple of hundred microamps movement on a clamp meter. That's seriously stable. Okay, so now I'll get this mere test all out of the way, and then we'll test the resistance measurements and see how we get on with them. Okay, DC resistance measurement. This is our residual. We're set to zeros on here. We've got 0.2, which is all fine. We can go up to 500 kilo ohms if I remember correctly. There's 10 ohms. Let's just try 0. Go 10 ohms again. Yeah, that's alright, isn't it? Let's go 110. Let's go 1K1. That's another 10K. We are 11.1K, which is about right. Let's just knock them all down to zeros. That should be our 10K, which is 9.99, which is all good. Let's put 100K in there, so now 110K. And There's our 500k and we're reading 500 dead on. Okay, so it doesn't appear to be any problems with the resistance measurement there. What I want to do is set this all up on an AC circuit with some DC milliamps injected and just see if that affects the accuracy of the current clamp. So what I've set up here is a little mad experiment to measure the DC actually on an AC circuit. I have a little board here to rectify and put some DC power in through my loop. I've got my Fluke 1587FC, which is in series with our TIS570, so the readings on these should actually match. We have our RCD here, and then just out of picture I've got a little transformer, you'll hear that buzz up, just to provide me with some AC load as well. So we are not quite zero, so we will put on our 0 there. We will switch on, and you can see now our reading is 4.7 milliamps, 4.6 against 4.78, which is pretty acceptable. We can just flip to AC as well, so you can see there fairly comparable readings there. But we've also got, now the only downside to this is if I flick back to DC, if I flick back to DC there, you can see we're a little bit out because this isn't zeroed, and you can try see, I get different value zeroing possibly when you're out of the circuit. So you can see I've gone the other way now, I've got 5 milliamps instead of 4.8ish, just because I've zeroed it in a different position. So I actually have to switch off really to do the 0. Let's see, then we're back to our 4.8, 4.78, which is all good. So what I'm just going to do, this is all manual, so I'm going to swap over some different resistors to give some different value readings on the instruments. So we're set up again with a slightly different value resistor. This should now give us 6.8 kilo ohms, should be around about 30 milliamps when we turn on. And then we've got 30.9 versus 30.56, which is near enough for me. 300 microamps out, yeah, we'll take that, won't we? So that's our 30 milliamp load, which again seems to be comparable. I'll swap it over to give, I think we're going to 50 milliamps next. Okay, we've swapped around again. This will be my final test. And you see we are now at 47.7.6 against 47.36. So a little bit more movement on the TIS570 in comparison to the Fluke, but the Fluke's in series with the actual circuit, so it is always going to be a little bit more stable. But you can see readings are comparable. Perfectly happy with that, even though we've got some AC running around the test circuit. The problem with DC mixed up within the AC circuit is that RCDs or RCBOs, the type AC type, can sometimes be blinded. I haven't managed to blind this one. This one is still tripping, even with a tester on there as well. It will still trip out, so perhaps I haven't got enough DC current going into it to be able to do that. But that's the reason why you will be checking for DC current within the UK, where AC RCDs and RCBOs are still fairly commonplace, although they are slowly probably being replaced with the Type A now, especially since the change in Amendment 2 of the regs. The only thing to be slightly wary of is that this does appear to be very susceptible to radio interference. You can see I'm all switched off and we're back down to our 0 and more or less zeroed. If I grab a hold of my wireless mic and bring him in closer, you can see what happens to the reading on here. That's just radio interference, so it's worthwhile being aware of that if you've got a really erratic reading. You can see it's not affecting my Fluke, but it's affecting the current clamp here. That did have me confused for a wee while till we resolved that one. But yeah, just to be aware of the fact it seems to be a little bit susceptible to radio interference. So I did say we'd just take a look at the access these caps provide into terminals. These are the SAK terminal range here. I've had to plug them into my Keysight instrument because this only has a 500 kilo ohm range on it, and the short resistor in here is greater than that, so you don't get a reading on that anyway. But we can go to our earth here. These are the SAK10 terminals. And you can see we're getting a reading there. And if I go to the SAK4s, you can see I can get in there and get a reading. SAK 2.5s, these smaller ones here, I am actually struggling. I can't get in. The earth terminal can get in, all okay. Obviously without the cap on there, I'll get in the 2.5s, no problems. Standard SAK4s and above, you're fine with. SAK 2.5s, I had to remove the caps in order to get them into the terminals to make a connection. So just briefly compare these to the Mega DCM305E and our Gossamer Metroclip 61. The immediate thing you see about these is the size of the head. The TIS is much smaller. Now, if you've got a set of tails, usually the tails have a fair bit of flexibility in them, so it's not too much of an issue. So we've got around about 25mm bore there against the Mega. There's 42mm, and our Gosson's a little bit smaller, 40mm for our Gosson. So as I said, usually there's enough room in the tails, and you can get two tails through this, but if they're spaced quite tight and you can't pull the tails together, you might struggle getting this round when you're using the AC leakage current method and you're clamping around both the tails. Not so much of an issue with these two here. But this is my first TIS instrument that I've ever used, and I'm actually quite impressed with it. Construction wise here, it seems to be a fairly good quality build. There's not much play in the jaws. The jaws on these are quite stiff to move. That seems to be the same for all of these style of instrument. They're usually a bit harder to open up than a standard clamp. So in terms of price for this, this ranges from around about £250 up to £300. So they're available from electrical distributors. CEF have a fair bit of TIS equipment in. I got this one from Thomas Electrical Distributors because it was slightly cheaper. I paid around £250 for this one. In terms of price against other clamps, that's a similar sort of price to the Mega unit. Metroclip is a bit cheaper, and these earth leakage clamps go from around about £100 all the way up to £800 for a unit from Fluke, but the vast majority of them cannot read DC leakage current. This is one of the only ones that can seem to do that, along with the Uni T one. So overall, I'm quite impressed with this little TIS unit. I had a look at some of their other stuff. For my field, they do have a 5 kV tester in there, and some heavier duty current clamps, power clamps, and a earth resistance clamp as well, which might be interesting to look at, which I may do over time. But then again, it's taken me about 5 years to get hold of one of these, so don't hold your breath with that. But that'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.